Okay, we're going to do this worksheet that's got some examples for your homework from next to the last section in Module 1, which is 2.1. We have several different kinds of problems in this homework set. Some of it is just having you solve single variable equations for the x or whichever variable it is, but in, just reviewing all the different types of forms that you might have to deal with, like you have to simplify one side or perhaps clear some fractions in order to get your answers. We have a few problems that are, I guess you could just call them rearranging formulas. So like this formula right here, it's got 5 variables and it's solved for C. We want to rearrange it so that it's been solved for Y. The same thing over here, we're solving this one for T. And now all of these formulas are many and varied. So I just picked a couple of examples, but you could have any kind of formula that we need to rearrange, and it's basically just the same steps for solving. We're just treating all the variables as though they were numbers. And then it also has several word problems in here, and I decided to focus on the one word problem that seems to give students a lot of trouble, which is when you have something that has been increased by a certain percentage rather than a flat amount. Like we've been talking about earlier, the linear functions, the slope represents how much something has had another value, a change value added or subtracted to it. But these kinds of problems have a certain percentage that has been multiplied against the original amount and then added or subtracted. Okay, so let's just go through and I'm just going to work through the examples. This first one is going to be solving for x. When you have an equation that has variables on both sides, what we want to try to do is make sure that we have simplified each side of the equation separately, because you have a separate expression or function on each side. In this case, we have the parentheses, so we're going to distribute the parentheses and call that 4x plus 12. The right-hand side really doesn't have any simplification necessary. It already is as simplified as possible, so we'll just copy it down to continue working in an equation. Once you have each side of the equation simplified as much as possible, then your next step is to try to collect all the like terms that contain the variable that you're solving for to one side or the other, put them all in one function. So since I have a 4x on the left and a 7x on the right, we can just choose which side we want to combine them into. I'm going to move mine to the right just because I like having a positive coefficient in front of the x. And if I move the 7x over to the left, it'll be negative. So I'm just going to remove the 4x from this side by subtracting, and I'll be left with just the 12. And then over here, I combine the like terms and get 3x plus 12. Okay, so we have taken our two x terms here and combined them into a single x term, which I have written on the right as 3x. And then once we get it to this point, we just take everything else that is on the same side of the equation or in the same expression as the x and eliminate all the other values, because I would eventually like it to just be plain old x equals the value. So when you have a multiplier and a separate constant term, we typically take the constant term and add or subtract it to remove it from that side and make the side that contains the variable even simpler. Whatever you decide to add or subtract, you have to do the same thing to the other side, and that just happens to turn into 0. And then no matter what number this is, if it were 0 or any other number, we still look over to where the variable is to decide what step we need to do for solving. So since it's 3 times x, and I just want x, which is like 1x, I want to change the 3 to the 1, so we're going to divide both sides by that coefficient, and of course it'll still stay 0. So this first expression, the solution, or the first equation, the solution is 0. Okay, the second one, we're dealing with a couple of fractions. We have a denominator of 4, and then down over here on the far right, we have a denominator of 6. And so there are lots of good ways to get started. A lot of you are going to want to expand those parentheses like we did on the left side over there. That's fine. But we also kind of recommend getting rid of these fractions if possible. So that's what I'm going to choose to do. I'm going to take each term. We have this first fraction, we have the x, we have the 1, and then we have the x over 6. I'm going to pick the common denominator, least common denominator between 4 and 6. And if you can also call it the least common multiple, in other words, the smallest number that divides by both 4 and 6. And if we go and we multiply every single term across the entire equation by that same constant least common multiple, it should be the fact that we should be able to cancel out our two denominators. So between 4 and 6, I always start with the bigger number, check and see if 4 goes into 6. No, so then I do the next multiple of 6 is 12. Check and see if 4 goes into 12, and sure enough. So our least common denominator, or least common multiple, will be 12. So I'm going to multiply each one of these terms by 12. So 12 here, times 12 there, the 1 times 12, and the x over 6 times 12. So right here, when I do this fraction times 12, when you're multiplying with fractions, think of it as 12 over 1. And then we should be able to cancel our denominator. It should go in there evenly. So really I'm going to be taking a 3 on the outside, multiplied through all this in here. Now, they're also going to be distributing a 3 on the inside. So there's 2 3s getting multiplied together here. So it's like taking 9 through the parentheses. So I'm going to get 3 times 3 is 9x minus 3 times 3 is 9 times 5 is 45. So all of this cooks down into 9x minus 45 all over 1, so I don't have to write the 1. And then the next two pieces are easy. I'm going to do subtract from this subtract, x times 12, 12x. Make sure I copy down my equal sign exactly where it's supposed to be. It's very important. Now on the right-hand side, I've got a 1. I'm also timesing by 12, so 1 times 12 is 12 minus. And then here's another one where I'm doing a fraction times a whole number, so we'll just put it over 1. And because I chose that 12 the way I did, I know that it should cancel with the denominator and make a 2. So the x times 2 will be 2x. So I've taken this original expression that had a fraction on the left-hand side and a fraction on the right-hand side. I multiplied every term by 12, and I've gotten this new one that looks kind of a lot like what I had over here on the left. I've got the left-hand equation, 9x minus 45 minus 12x is equal to, the right-hand function is 12 minus 2x. Okay, now that on the right is as simplified as it can get. There aren't any like terms or parentheses or anything, so we'll just copy it down. But over here, I can combine my 9x and my negative 12x and make it negative 3x minus 45. Okay. Let me see here. All right, so now what I'm going to do is I'm going to collect my x terms to one side or the other. I guess I can do like I did before and add the 3x so that I'll get a positive x over here. That'll give me 3x minus 2x is just 1x. Negative 45. And then I'm going to subtract 12 from both sides. That'll give me negative 57 equals x. Okay. So hang on just a second here. All right. So x equals negative 57. I think that's right. I may have to check that later and see. Okay. Let me check something here. So I'll have 3 x minus 5 all divided by 4. Then I'll add subtracting x, and then that is 1 over x. Got it. Right there. Okay. So yeah, that looks about right. So, all right, I was just double checking my answer to make sure that looks right. Oh, that's my dog. Okay, sorry about that. And trace. Yep. Okay. So negative 57. Sorry about that. All right, now the next one is in a formula. Let me get back here so I can see what I'm sharing with you. Okay. So I want to solve this for a y. Right now the c is isolated. So when it says solved for it, that means you want it to look like this. The y by itself on one side and then all the other variables moved over. So If you don't have any simplification, in other words, there's no like terms on the left-hand side here, there's no parentheses to distribute, then what you want to do then is take all the terms that are with your variable that you're trying to solve for and move them to the other side. So the AX is a separate term, so I'm just going to subtract it to the other side. So I'll have BY by itself, and then I'll have the C that was already there, and then minus the AX term that I'm moving across. It's just like over here when I was taking the term that wasn't with the X and subtracting it. Or over here, the 3X plus 12 and subtracting it to get the X by itself. And then what do you do in the last step? You take whatever is with your variable and divide it. So since the variable has the B number in front of it, we're going to divide both sides by B. And that's what my final answer is going to look like. It's going to be C minus AX on the top, all of that over B. Now, if you would rather divide each piece separately by the B, you can, but you would have to actually write the subtraction between the two separate fractions, and they would both have to be divided by that B. So I'm just going to do the lazy math thing and just write that B once, so all of it gets divided by B. So that has been solved for Y. It's no simpler looking. In fact, it looks a little more complicated than original, but it's been solved for the variable they asked us for. That's all that we're supposed to do. Okay, so the last one, solving for T. Notice where the T is. It's inside these parentheses here. Okay, so probably what most of you will want to do, you don't have to start it this way if you think of a different way to start, but a lot of you are going to want to go ahead and multiply your parentheses through, so let's do that. I'm distributing the Q, so Q times 1 is Q, plus Q times RT would be QRT. I will say this about the My Math Lab formulas that have uppercase and lowercase letters. They're really picky about continuing to carry those cases, whether it's a capital, like an uppercase or lowercase letter. So don't switch a lowercase t to an upper T or whatever, because it'll count it wrong when you type that into the answer. Okay, so now that I have everything distributed on the right-hand side, I'm still trying to isolate that T right there. So there's two terms again. So first what we're going to do, like we did over here, is take the term that doesn't have the variable with it, which is just Q, and we're going to move it to the other side by subtraction or addition. So we'll have B that was already there minus the Q that I'm bringing over equals that remaining term QRT. Okay, and then what I have here on this last step, I'm still trying to solve for the T. I only have the one term. Remember, terms are things that are added. So just the one term, and it has two multipliers with it. So to get the T by itself, I need to divide those two multipliers, and I can do that in one step like this. So the Q's and the R's cancel, so that'll give me T equals this fraction, B minus Q, all over QR. And again, I'm not going to carry it through, but if you want it, some of you are really going to want to cancel those Q's. It doesn't make it any simpler to do that, but if you wanted to write it as two separate pieces, you would have to do that before you cancel the Q's here, because just because you cancel them here doesn't mean it wouldn't still be showing up under the B. So I think we need to, I'm just going to write it all in one piece like that and have that be the end of that. So that's just rearranged so that it solves for T instead of the original form where it was solved for B. And you're going to have other formulas in the homework that aren't like exactly like either one of those, but that's the idea. Okay, now I'm just going to focus on this one kind of word problem where we're doing a percent of increase and decrease. And I thought I would start by having you guys, everybody should be able to turn off your calculator or hit pause. I mean, turn off the video or hit pause and work this out, because this is an algebra. Anybody that is a server out there, you know how to do this really fast, probably in your head. But what's the total bill going to be if the bill plus tax or whatever is $45.50? The customer is going to tip 18%. So how much is the customer going to pay altogether? So a lot of you have your own ways of doing this, but basically you take your original cost of the meal, you're going to add your tip, and your tip is going to be calculated by taking whatever percentage times the original amount. So let's figure out what that tip would be, and there are other ways to do this, but this is what most of you probably think to do. 18% of $45.50, $8.19. So the tip part is $8.19 And then I was going to add that to the 4550. Added to 4550. It's going to give me 5369. Okay, so I'm going to talk about other ways to do that calculation, because what that says is if I start with 4550 and I increase it by 18%, I increase it by 18%, I get 5369. Okay, so here's another way you can think of doing this, because let's look at the next question. And let's say we were trying to work backwards from the 5369 and get back to the 4550, because that's often what we have in some of these percent change problems. That's what these are called, percent change. So rather than like a line where we're adding the same amount, for percent change problems, we're multiplying by some amount and then adding it to the previous amount. So now it's working backwards. If the total cost of another bill, including the 18% tip, is $29.50, they're wanting us to work backwards. So let's practice on this one first. So how could I start with 5369 and 18% is what we know is the percentage of the tax, and figure out how to work it backwards and figure out the original bill was 4550. I'm going to tell you what, it's not. Let me show you. A lot of you think, well, I'll just subtract it. I'll just do 18% of this number, 5369, right? You're thinking that might be the tip, and then you're going to subtract that from the 5369, and you are not going to get 4550. So I just want to prove this before we go into what really works, why this doesn't work. See, this is 4403, but we're trying to get back to 4550. The reason is right here. If I take 18% of this larger amount, that's not going to give me the same amount of tip that we calculated, is it? Because when we did the tip, we were doing 18% on that smaller original amount. So it is not a valid way to solve this problem to start if you're given the final amount, including that percent increase, and trying to take the percentage on that final amount, because that's not the number that was added or subtracted. Okay, so what we do instead, this is an interesting thing. I'm going to see how both of these calculations involve the 4550. You could also think of this as taking the 4550, and instead of doing it in two separate steps where we do the 4550 and then we add 18%, kind of think of it like factoring out the 4550, and you get, look what you have here. Okay. If I multiplied this out, that's exactly what I have written here. So if I want to increase 4550 by 18%, this is a faster way to do that. Okay, what you can do is just take 4550 and do one multiplication by 1.18. The 1 is the part that adds it back to the original amount, and the 0.18 is the tip. And when you add a whole number and a decimal together, that's what it looks like. So the number in front of the decimal will be 1, and then the number after the decimal is your percent change. If you multiply that directly, that also gives you that 5369. Watch, 4550 times 1.18, but 5369. So it's a bit faster to do it that way, and it's a really handy tool if you have to undo it. Okay, so I'm going to give you kind of a little bit of a percent increase formula here. I'm just going to talk about the old amount and the new amount. Okay, if you take your old amount and you multiply it by 1 plus your rate kind of as a decimal, you will get to your new amount. And R is your percent change as a decimal. Okay, so you take your old amount times 1 plus the rate as a decimal equals your new amount. I'm just making a note here that make sure you convert it to a decimal. All right, so let's look at this then. 2950. Let's run this. So the final amount, the total cost is your final amount is 2950. That's this part here. 2950. And that was taking some old amount. I'm going to call that X. And what was the percent? 18% as a decimal. So look, if you're trying to get from the new amount back to the old amount, you're actually going to divide, not subtract. That's kind of counterintuitive, but once you get the hang of that, that makes these things really fast to do. So $29.50 was my final amount. I'm going to divide it by 1.18, and it says I started at $25. Okay, let's check that and just see if that's right. $25. We're going to go back to the old way. 18% of $25. I'm doing 0.18 times 25. Then I add all that together, $29.50. That's exactly what they told us the final amount was. Okay, so the cost of the meal alone was $25. Every once in a while, you're going to get this question also in the homework, where they'll say, oh, well, what was the amount of the increase then? Or what was the amount of the tip? Or what was the amount of the commission? You know, those kinds of things that are figured out on percentages. So remember, you can either just do 18% times your old amount, or you can just subtract the difference between the two because it's the same thing. So it went up by $4.50. So you can either just subtract your new and old. That's your old. The new is $29.50, or you can actually do the calculation, 0.18. Now that you know the original amount, you can work it out, $4.50. Okay. So this formula right here, it helps you to convert from the old amount to the new amount, or the new amount to the old amount, if you know the percentage. It doesn't tell you the tip, though. If it wants the tip, you'd have to do an extra calculation to figure that out. Okay, and then the last one, it's the same idea, but what if you have something that is depreciating over time? Like, you know, the pandemic has hit, and so housing prices, or I don't know what would be decreasing, but things that people normally do aren't doing now, so that the value is dropping by, say, 5% every month or something. Or let's say this, you have a sale. So we've marked everything 40% off on the sale. And so now we know what the sale price off. The sticker price is showing $33.60, and no matter how much you pick at that sale price, you can't get it off to see what the original price was. But this is also a way you could check and make sure that it's been reduced properly. So what was the original price? So for a percent decrease, let me just give you a little guideline here. In this case, the old amount would be bigger, wouldn't it? So for the old amount, you're going to do the original amount minus that percent decrease. And that's going to give you your new amount. So the old amount will be bigger, the new amount will be smaller. Okay? So also think of it this way. If they have reduced the original price by 40%, and what we have left now is this amount, wouldn't this remaining amount be the 60% that they didn't reduce it by? So that's where you get your 1 minus R. So now it says, what was the original price? So I don't know what that is. So that's going to be my X. It's going to be 1 minus, what was the percentage? 40% as a decimal means my rate is going to be 40% as a decimal would be 0.4. So there's taking off 40% right there, subtracting 40%. And that's going to equal my new sticker amount, $33.60. That's my new amount. Okay, so this is what, remember when I said if you take off 40%, you're left with 60%? That's what this is going to do. 1 minus 0.4 is 0.6. And X, just flip it around there, equals $33.60. So if I've taken away 40%, what I have left is 60%. So 60% of the original price is represented by that sticker price. So we're going to divide. So all of these, when you're working backwards to your original price, it has been increased by a percentage or decreased by a percentage. You're going to end up dividing to find your final answer. So let's see what it is. So we've got $33.60 divided by 0.6 is $56 originally. So the original full price was $56. Okay, so that is how you do this is the general way that you set up something that's been decreased by a certain percentage, and this is how you set up something that was increased by a certain percentage. So those would be things you might want to have in your notebook so that when you're working through the homework, when this My Math Lab comes back up, I hope soon, you'll have some notes about how to attack those kinds of problems. Okay, so that's enough of that. Let me get everything stopped again.